Welcome to Science, Mr. Robertson. Today, video about light. This is so cool, watch. Woo, I love this. Light is awesome. We did the eye, and now we need to look at the light to understand a bit of the physics about how light actually works. Light is amazing. It's something science doesn't really understand. We do know it is the fastest thing in our entire universe. We are talking about a speed that is 300 meters every second. To compare, Usain Bolt at his fastest, he's about 12 meters per second. That light is so fast. So fast. When you turn light on, you can see the light immediately hit you. It travels so incredibly quickly. We need to know a few basic rules. And the first one is, of course, that light can shine in all directions, but each little bit of light only goes in one. Light travels in one direction. And it always will. That it will continue going in one direction until it stops. It can stop in many ways. It can hit something. And the best example of this is when a shadow is made, like the one probably on the wall behind me right now. Shadows. Shadows are basically formed when it's impossible for the light to be able to get through an object. So if I have some sunshine here, and I have a person here, then we know there'll be a shadow. That shadow is made because the sun can only go in one direction. It can't go and jump around and go to the other side. It travels in a straight line. So here in this person, there can be lots of light here, for example, but up to here, there'll be a shadow. A bit like so. Go to here, you can see here, this is where the shadow is made on the floor. Like so. It's the bits from the top to the bottom of where that person is. There can be a shadow made. Here, lots of light. Here, lots of light. So a shadow is made where the light cannot get through. In this example here, most of that light is probably absorbed. It takes up, and it goes in the material. You know that because if you go outside in the sunshine, you absorb the heat from the sun, and it feels much warmer. So we can absorb light. We can also reflect light. Not just absorbing, we also do reflecting. The best example of reflecting is probably to have a mirror. In science, we usually draw a mirror like this. I should be doing straight lines. I'm not a bad person. And if I have light coming in, then that light can bounce off. And if doing a bit of maths, this angle here is the same as that angle there. It bounces off exactly the opposite to as it comes in. And by reflecting light, then I can, of course, bounce it around different places and I can see different things. Light, remember, comes in many different colours. You can have your rainbow, for a start. Your rainbow of colours, your spectrum, we can say. Starting at red and going all the way through to purple. And there's all the different colours in there. I have a blue pen and a red pen. That will have to do. My rainbow of colours. Like so. Light is actually much more than that. It's a whole spectrum of all the colours. And I can even go further red, and I can get infrared, like remote control of my TV, and microwaves and radio waves. And I can have here things that go like UV, ultraviolet light. That's the light that can maybe make our skin burn from the sun. We can have X-rays. There's actually lots more, but what we can see is this little bit in the middle, the visible light. And all of these colours together make white. White is a combination of all the different colours. It's a whole mismatched craziness of different colours of light. And that is coming up here. I've got beautiful white light. All the different colours are shining. And then on my body, the little bits that reflect show the different colours of my shirt. White bits, blue bits, black. Black means everything is absorbed. There is no light left. So on the black bits here, that's all of the light being absorbed. Cool. One final thing, and that's about something, of course, to do with the eye, and that is lenses, and how lenses actually work. Because people who have glasses, they're actually changing the direction the light moves in. It's a bit hard to explain, but let's have a go. Let's say somebody has glass. It's a bit like this. It's this shape. This shape here is actually called a convex lens. And I'm going to have some light coming in from far away. Here's my light. Light's coming in. It's coming in, it's getting closer, it's getting closer, it's getting closer, and wham! The light hits the lens. Now, you have to try and imagine that each of these little bits of light is like a little tank, a little car. So I'm going to zoom in. Can you see? Yes, you can. On this bit here. Like so. This is glass, and this is air either side. Now, the light goes a tiny bit slower in the glass compared to the air. So I'm coming through, and the left side touches the glass before the right-hand side. So it's going in a straight line, and then this bit hits the glass first. So this bit goes slower, this bit goes a bit faster. It's not slowed down yet, so this goes like so. Then when they both hit the glass, they both go the same all the time. So this bit here, the left-hand side goes slower, so it starts to move in. This bit here, both get the same time, it keeps on going straight. This bit here, the right goes first, slower, it comes in like so. What happens is the convex lens helps this light get to the focal point here, where all of those light rays meet. That's where the focus, all of that light energy goes to that one point. The opposite of that would be to have a concave lens, which is like this shape. And let's have our 3 bits of light once again. Getting closer, getting closer, getting closer. Wham, wham, wham. Now here, the left hits first. So it's going to go to the left. So this goes out the opposite way. This one here goes straight through again. This one here hits the right first. It's going to slow down to the right and turn to the right. This one comes down here. This one actually spreads out the light. So if your focus in your eyes was too close to the front, you would get some glasses like this, so it went further back to the right place. If you were focusing the light in your eye too far back, this lens here would help bring it forward. I'll leave it there for today, but thank you very much. Take care.